Hey guys, I'll be taking on this question E, clique partition of last Codeforces educational round. So first let me tell you what the question was about, then we can move on to the solution. So in this question, basically you were given two integers, n and k, and you have n nodes in a graph, and each node you have to assign one number from 1 to n, and these numbers should be distinct. So basically a permutation kind of thing. Let's say 1, 2, 3, 4, 5, 6, and 7, and 8. And after that, you join two nodes with an edge if if this condition satisfies. And the condition is that absolute value of ai minus aj, this is a is the number that you have assigned 4 and 5, plus abs I minus j, that is the I and j are your number of nodes, the node number should be less than or equal to k. So after assigning these numbers, you add edges to this graph, and let's say these are the edges that you were able to add. Let's assume that. After that, you must partition this graph into cliques. What is a clique? Clique is a graph in which all nodes are connected with each other. So basically, every node is connected to other node through an edge. So you have to partition this graph into minimum number of cliques. So let's take this example. Uh, this is one clique. This is another clique, and this is another clique. So you can partition this graph into three cliques. Basically, the problem that you have to solve is that you must assign these 1 to n distinct numbers such that you get minimum number of cliques. So this is your problem. So let's take on the first example. Let's take on the second example. You have 5 and 4 with you. N is 5, K is 4. And the assignment that is done here is 3, 1, 5, 2, 4. So 3, 1, 5, 2, 4. So if you draw this graph, 1, 2, 3, 4, 5, and 3, 1, 5, 2, 4. Okay, your k was 4. So will there be an edge between? Yes, there will be an edge between 3 and 1. Will there be edge between 3 and yes? Will there be edge between 3 and 2? Yes. Will there be edge between? So there's going to be, you won't have an edge between node 1 and 5 because k here is greater than 4. So let's come to this one. Will there be edge between 1, 2 and 3? No, there won't be because again it's greater than 4. 1 and 2, yes, there is going to be an edge here. And 1 and 4, no, no edge. Again, yes, 5, 2, 3 and 4, 3, 1. 5, 4, 1 and 5, 4, yes. And with 2, will there be an edge over here? It's 1 and 2, yes. So this is going to be your graph. So you can see that this graph can be partitioned into, I mean, this whole graph is not a clique because you can see some edges are missing, but we can divide it into two cliques, and that is going to be your minimum number of cliques that you can find from this graph. And that can be, well, according to the solution here, your divisions are done 1, 2, and 3. 1, 2, and 1, 2, and 3. Sorry, 1, 2, and 4. So yes, this is your one clique, and then this is your other clique. And how did I find out this was the division? Uh, this is the division which is given in the solution, because it has asked us to, whichever nodes we decide to put into a single clique, we assign a single color to all those nodes. So basically 1, 2, and 4 are in one particular clique, so we assign color 1 to node 1, 2, and 4. And then 4 and 5 and 3 then form another clique, so we assign 2 to node 3 and 5 to denote that they are part of some other clique. So that's how we are going to denote it. So first we must assign these numbers AI, A1, A2, A3, A4, A5. Then we must find the minimum number of cliques, and then we must print our division, which node belongs to which clique. So these three things we have to do here. So how do we approach it? So basically, if we had to brute force it, we'll try every possible permutation, p1, p2, p3, dot dot dot, total n factorial permutations, and then form these graphs, n factorial graphs, partition them into cliques, uh, x clique, x1 clique, x2 cliques, x3 cliques, and whichever x is your minimum will return that particular clique division. This is how your brute force would work. But as you can see, this is an n factorial solution. So obviously it is going to give you daily, since n can go up until 40. So 40 factorial is not going to work here. So what do we do now? How do we find our assignment permutation, the correct permutation? So I mean, this is like a general method in competitive programming, where if you have to find some sort of permutation or pattern or something like that, you can basically brute force. First we'll brute force all the permutations, like I told you in this case. Find all the permutations up until n factorial, and we'll observe those permutations. Let's say we found some random permutations which were giving you the minimum number of cliques. Let's say x dash is your minimum number of cliques that you can find, and these 4 permutations were giving you this x dash number of cliques. So we'll try to observe these permutations and try to look for some sort of pattern here. That I mean, is it completely random, or this permutation is following some fixed pattern? So for that, we have to brute force stuff and observe. So I'll show you the code, the brute force code. So basically, I'm storing my permutation in this B array, and then I calculate my answer. Basically, I don't calculate the number of cliques, but I calculate what kind of arrangement. Let's say I have 5 numbers with me. N is equal to 5. and I do some assignment here. 5 3 1 4 6. And if I assume that these 5 nodes form a clique, then which assignment is going to give me the maximum, which assignment is going to give me the minimum. I'm writing this down because it's important. It forms the core of this problem. Minimum value of k that will allow this clique to be formed. So for example, if your k is 40, so whichever assignment you do here, this is your indexes and this is your permutation. So whichever permutation you put here, p1, p2, p5 factorial, all of them, these 5 nodes are going to form a clique regardless of the permutation you put here, because k is very large. This term ai minus aj plus I minus j is always going to be less than k, because k is very large. So let's say I start to reduce this k. I bring k down to 30. Let's say I bring k down to 20. I bring k down to 5. I bring k down to 2. So what is the minimum k for which I can find an assignment? So that is my goal, and this is what I will find using this brute force code that I have written. So for every assignment, I add edges. I assume that each of any 2 nodes have an edge between them. I find the distance between the term which I need to find, and I store the maximum of those terms. And let me show you. Yes. So you can see for this permutation, for this assignment, if we assign this particular permutation, the maximum value of that term is going to be 18. So these 10 nodes can form a clique only when k is greater than 18, greater than or equal to 18. And then if we look at these values, let's go with a smaller value, because there's just too many permutations here. Let's take 8, 7 for example. So with 7, if you observe the minimum value that you'll get here is going to be okay. We can check what kind of values are we getting. So do we get, if we get m is equal to 1, we'll print a permutation. So we don't, well, no permutation gets printed, so we do not find the max value of the term which is equal to 1. Let's go with 2. We don't find any. Let's go with 6. We don't find any. Let's go with 7. We do find many permutations, which if we form a clique using this particular permutation, it is going to your k needs to be greater than or equal to just 7. So this is the general observation that we'll make here. The general observation that we'll make here is, if you have, let's say, 8 nodes, 1, 2, 3, 4, 5, 6, 7, 8, and you had to assign a permutation such that least value of k allows it, so that value of k cannot be less than equal to n. It's always going to be greater than or equal to n. So if you have n nodes with you, there exists a permutation such that you can form a clique using these 8 nodes, and your k can be as low as 8. So from here, what we are going to do is, basically, let's say you are given n is equal to 25, k is equal to 10. So we have to form the minimum number of cliques. So what we are going to do is, we're going to take first 10 numbers. We're going to take first 10 numbers, assign a permutation here such that these 10 nodes form a clique. So basically, point I'm trying to make, what is the maximum number of nodes that I can take such that they form a clique? So we know that k is equal to 10. So if I take 5 nodes, will I be able to form a clique using these 5 nodes? Yes, I will be. If I take 6 nodes, will I be able to form a clique? Yes, I can. If I take 10 nodes, will I be able to form a clique? Yes, I can. If I take 12 nodes, will I be able to form a clique? The answer is no. And answer is no because all these previous experimentation that we did, this was the conclusion that we reached, that if your k is equal to 10, so the maximum number of nodes which we can put into a clique cannot exceed 10. So if you have 25 with you, so we'll take first 10 nodes, we'll take other 10 nodes, next 10 nodes. This is a one clique, this is your second clique, and then the remaining form a clique, and the remaining form the third clique. So basically, this is how you find the number of cliques. All you have to do is n by k seal. This will give you the number of cliques. And what about the permutation? The permutation is going to be, again, what kind of permutation we are going to have is, we can again observe it here. So when n is equal to 7 and k is also equal to 7, we get this permutation. So you can see here a kind of pattern is being followed here. 1, 2, 3, 4, 5, 6, 7. And if we change it to 9, again you see 1, 2, 3, 4, 5, 6, 7, 8. So we can clearly see a pattern here. You can check for other numbers as well. So first, what you do is, let's say 1, 2, 3, 4, 5, 6, 7. These are your indexes. First you assign reverse of this 5, 4, 3, 2, 1, and then shift it by n by 2. So if you shift it by n by 2, this is how it is going to look. 7 will come in the middle. 1, 2, 3, 4, 5, 6. And for even numbers, your pattern would look something like this: 1 2 3 8 7 6 5 4. Let me check once. Yes, this is how it looks. So you can simply store a permutation, reverse it. I mean, store this permutation, the straightforward one, 1 2 3 4 5 up until n, reverse it, and rotate by n by 2. You can use rotate function to shift these elements. So that is how you are going to assign these numbers. So you had 25, n is equal to 25, k is equal to 10. So 1 2 3 4 5 6 7 8 9 10 11 12 20 21 up until 25. So this permutation can be created using these numbers. Like I told you, reverse them, rotate them. This permutation can be used using these indexes, and this permutation can be built using these indexes. And then you had to assign colors as well. So you simply apply color 1 to all these nodes, color 2 to all these nodes, and color 3 to all these nodes. So this will solve your problem. So I mean, I understand this was a pretty complicated problem. I mean, all that brute forcing and observation and everything. So try to give it some time. If you are having a hard time understanding it, you can like go through this video again or try to look at the tutorial. But it's not that difficult. You'll understand it once you give it some time. And the code part, I can show you the code, but I would recommend that you do it on your own, because I mean, its implementation is very straightforward. So basically, you find your number of cliques, and for each clique, you take like the next 10 elements, first 10 elements, next 10 elements, and the remaining elements. You reverse them, you shift them, assign that, store that permutation, and you assign your color to these nodes. And then at the end, you print everything. So if you have understood the concept, I mean, implementation isn't that difficult. So okay, that's all for this one. Okay, bye. Thanks, guys.